So we're looking at domain and range and finding this function's inverse. So we'll start with domain. I do see that I have a fraction here, so I want to make sure I'm not going to divide by 0. I notice in the denominator of this fraction you have 4. So we don't have to worry about dividing by 0. The bottom is fixed at 4. In the numerator I see a square root. I want to only take the square root of things that are greater than or equal to 0. So you say, well, I'm dealing with x minus 5. How can I ensure that that is greater than or equal to 0? You can solve this inequality by adding 5 to both sides. Right? So you end up with x is greater than or equal to 5. Well, how do you describe the set of numbers such that x is greater than or equal to 5? That's closed 5. It's open infinity. There's your domain. Okay, range. Well, let's consider where x is. X is only in one spot in this function. Okay, it's underneath the radical there. So as far as this green piece right here, well, if x can be everything from 5 to infinity, then what you see in green there is going to range from 0 to infinity. So you're going to take, green is going to be from 0 to infinity. You're going to next divide that by 4. Well, if you divide that by 4, the number set from 0 to infinity, every value divided by 4. So we'll say divided by 4. Well, you still produce the number set from 0 to infinity. Now, don't forget, you got to subtract 13. So take all those values and subtract 13. Now you're dealing with negative 13 to infinity, and that's the range. Okay, next, let's find f inverse. So we start with y equals square root x minus 5 over 4 minus 13. I'm going to go ahead and add 13 to both sides. Y plus 13 equals square root x minus 5 over 4. I want to isolate x. I'm one step closer if I multiply both sides by 4. 4y plus 13 equals square root x minus 5. I'll square both sides. So I've got 4y plus 52 squared equals x minus 5. Whoops. I'll add 5 to both sides. And now I have found f inverse. So f inverse of x equals quantity 4x plus 52 squared plus 5.